So Dave, I'm hearing a lot about transformer models. Can you explain to somebody who knows nothing about generative AI what transformer models are?
Yeah, transformer models are a type of generative AI architecture that came in 2017, and they're mostly used for natural language processing. And they use a very simple principle of something called attention, and it's actually very similar to how we as humans understand language. So I'll give you an example. Say I said to you, the pink elephant wanted to get into the car, but it was too, then naturally you're thinking of words like big, anything to do with the fact that it's enormous. Now, what we're doing is we're looking back at previous words in that sentence, so the word elephant, the word car, and we're using that to decide that the size is therefore something that's important. They're the words that draw our attention. The word pink is irrelevant, and so we place no attention on the word pink in that sentence. Now, let me give you another example. If I said the pink elephant wanted to get into the swimming pool, but it was too, then size isn't so important, so we're looking at words like scared. And it completely changes our understanding of the sentence just by tweaking one or two words. Attention is the mechanism that unlocks this power of the transformer and is the real driving force behind many of the most impressive models today, such as GPT and ChatGPT, which I'm sure you've heard of.
Fantastic. Now, I've been hearing a lot about diffusion models recently. Can you explain to me in the simplest terms possible how diffusion models are used in generative AI?
Yeah, diffusion models are used in models such as DALL-E 2, Stable Diffusion, Image Gen. They're used for kind of state-of-the-art text-to-image generation, and particularly for the image generation part of that. Now, the way they work is, imagine you've got effectively television static, complete random noise, and you want to distill out of that an image. So you're going to need to work out which pixels you need to adjust, little bit by little bit, until you get back to what looks like an image from the training set. Now, if you think about it, it's very easy to add noise to an image. You just keep adding little bits of noise until it looks like complete television static. It's very difficult to go the other way, but this is what diffusion models are trained to do. They're trained to take an image which is effectively pure random noise, and then bit by bit work out which pixels need to be changed in order to make it look like an image from that training set. So they're a really interesting kind of model that are dominating in many regards generative adversarial networks, which are another state-of-the-art method for generative AI, particularly image generation. So it'd be really interesting in the years to come to see which of these two types of models starts to dominate, GANs or diffusion models.
Brilliant, thank you.
No worries.